Hey there, Portable for parents and students. I'm just going to go over some of the review for the math test that is this week. And this is all on Chapter 6. It has a lot to do with numbers and different operations that you might want to do with numbers. I gave the students the 4-page review sheet, and I'm going to go through and make one video for each of the pages. Some of the stuff on each page is more geared towards grade 6, and some is geared towards both 5 and 6. So let's start off. The first half of this part on prime numbers and composite numbers is only grade 6. So only grade 6s need to worry about this. Let's start off with a definition of a prime number. A prime number is a number that is divisible by only 1 and itself. So for example, let's go for the number 5. The number 5, the only way to make a 5 is 1 times 5. 1 and 5 divide evenly into 5, but nothing else does. So 5 is a prime number. But other numbers have more than 2 numbers that divide into it. Let's say, for example, 6. So to make 6, I can do 1 times 6 and, of course, 2 times 3. So because it has multiple numbers that divide into it, 6 is called a composite number, whereas 5 is a prime number. Now, another interesting thing I learned is that prime numbers start with 2. 1 is not a prime number by definition. So the prime numbers start with 2. Let's make a little list of what numbers we think are the prime numbers. So again, I start with 2. 3 works. 4 does not work. So let's put the prime numbers here and the composite numbers here. 4 is a composite number. 5 is a prime number. 6 is a composite number. 7 is a prime number. 8 is a composite number. So far in this list, you can see that all of the even numbers, besides 2, once you get past 2, all of the even numbers are going to be composite. So if you get a number like 1,000,000, right away you know it's a composite number because it's an even number. Anything that has is an even number will end up being composite. So 2, 5, 7, you can go on and on. 8, 9 is not. So that's our first odd composite number, 9, because you can do 3 times 3. Let's see, 10, of course, is not. 11 is. In the end, there are 15 numbers that are prime if you start at 2 and you end at 50. So one good exercise would be to try to locate the 15 numbers that are prime, or as many as you can, from 2 to 50. So that's prime and composite. Again, that is a grade 6 section, not a grade 5 section. The grade 5s won't have that on the test. The next part I'm going to talk about is factors versus multiples. What's a factor of a number versus what's a multiple? A factor is all the numbers that divide evenly into a given number. And a factor and composite are kind of related. Whereas what is a multiple? Multiple is just kind of skip counting. Let me give you an example. Factors of 24. Well, let's see. Basically, what are all the numbers you can multiply together to make 24? This is the way I do it in an organized way. I know 1 times 24. So that means that 1 and 24 are both factors of 24. They both evenly go into it. I can go 2 times 12. I can do 3 times, help me out, 8, I think. 4 times 6. And 5, nope, no 5s, and that's it. So 24 has 8 factors. 1, 2, 3, 4. 12, 24, 8, and 6. So there you are. So that's what a factor is. If I give a number like 36 or 42 or something like that and I ask you which factors, I'm going to ask you to figure out all the numbers that you can multiply together to make that number. Multiples are a little bit different. Multiples, it's just really, I wrote up here, it's just like skip counting. So multiples of 9 would be 9, 18, 27, 36, 45. And traditionally, you see in a lot of textbooks it'll ask for 5 multiples of a certain number. So multiples are just skip counting, whereas factors are Factors are when you look at the numbers inside that that you can use to make that number. Okay, so that is the first page. The last thing I'm going to do is when you have a composite number, let's say something like 42. And sometimes on the questions, it will ask you to reduce the 42 down to the prime factors. Prime factors. And the best way to do that typically is like a tree diagram. So what you're going to do is try to pull 42 apart. What I mean by that is, let's say 42 is really, well, I know it's 2 times 21. So right now, 2 is a composite number. But 21 is not. 21 is, let me start again, sorry. 2 is a prime number, I can stop there. But 21 is still a composite number. I can break down that further, and that would be 3 times 7. Now both of these numbers are also prime. So if you were given a number and asked to break it down into the prime factors, you would pull it apart, find something you can use to multiply together, like I did 2 times 21 this time. And I keep on working on the numbers, the resulting numbers, until I'm left with a series of prime factors. So again, 42 then equals 2 times 3 times 7. And that would be what prime factorization is. Okay, there you go. Page 1. Away we go.